Welcome to Elixir Mix, your weekly Elixir podcast talking with members of the community. My name is Mark Ericksen. On our panel today, we have Eric Oestrich.
Hello.
And today we are joined with our special guest, Daniel. Daniel, can you introduce yourself?
Hey, guys. So I'm Daniel Serrano. I work at a company called Onfido, and we do identity verification at scale. I'm working off of Portugal, but we also have offices in London, the US, and some other places in the globe. I'm glad to be here.
This episode is sponsored by Sentry.io. Recently, I came across a great tool for tracking and monitoring problems in my apps. Then I asked them if they wanted to sponsor the show and allow me to share my experience with you. Sentry provides a terrific interface for keeping track of what's going on with my app. It also tracks releases so I can tell if what I deployed makes things better or worse. They give full stack traces and as much information as possible about the situation when the error occurred to help you track down the errors. Plus, one thing I love, you can customize the context provided by Sentry. So, if you're looking for specific information about the request, you can provide it. It automatically scrubs passwords and secure information, and you can customize the scrubbing as well. Finally, it has a user feedback system built in that you can use to get information from your users. Oh, and I also love that they support open source to the point where they actually open sourced Sentry if you want to self-host it. Use the code devchat at Sentry.io to get 2 months free on Sentry's small plan. That's code devchat at Sentry.io.
Awesome. Well, today we wanted to have you on to talk about some interesting different topics. One of which is something I've heard about, which is called mutation testing. And it's something that I understand you've taken a little bit more interest in exploring this idea. And there's some other topics, obviously, we want to talk about too, like distributed tracing, a lot of good stuff. So why don't you kind of open this up with kind of just explaining what mutation testing is?
Yeah, sure. So the idea behind mutation testing is really simple, and it dates back to 1978, if I'm not mistaken. And it's just a way for you to check the sanity of your unit tests. So when you write unit tests, you know that you're sort of biased by the examples that you find when you're like describing your tests, right? Like you write a test and when you append to a list, you know that the list has to have a size bigger than 1. But what you actually do is you test that with real examples. So you do like the empty list, and then you see that when you add an element, you check that the size of the list is now 1 and that the element is there. So what that can lead to is that you end up being a bit biased by the examples that you find. What mutation testing does is it tweaks bits of your source code, not your tests, so your actual source code that you've written, and it will go in, modify it, and then run your tests again and see if the test is still green. If it's still green, that smells like something fishy, right? Because you shouldn't be able to change your code and the tests still pass. It either means that you tested the wrong thing or that your code is wrong.
So to get a little clearer on that, so when you're talking about mutation, that's mutating my code, is that modifying the source files on my computer? I'm going to now have Git changes to review or anything like that?
So no Git changes. The thing is, so we will change the source code, but it will do it in a different way. So you won't have your Git history changed or anything like that. Ideally, the framework for testing, for mutation testing, will do this for you. So it will change the code that you have, and it will run your tests over and over again until it finds enough tests that are still passing that will make it consider it a red flag. If you have your source code changed and your tests still pass, that's not good. So there's this library that I've been writing, exavier, that we can talk about later in the show. It works it's inspired by 2 other libraries, PyTest for JVM-based programming languages, and Mutant from Ruby. And the way that the JVM-based one, Mutant, works is it changes the JVM bytecode. It has some benefits like speed, performance improvements, and also there are some things in terms of like the mutation testing lingo, like eliminating duplicates and whatnot, that can become easier there. But the really big thing is that I had this intuition about like changing the AST in Elixir because it's so easy to do in this language with all the meta programming that's available. And that's actually the way that Mutant from Ruby does it. It has a lot of that AST parsing side and whatnot. And so I thought that in Elixir, this should be fairly easy to do because we have all of that support for traversing the AST, converting code into the source, a source file. So like passing on from quoted code to string and whatnot. And so, yeah, that's the idea, I guess.
So if I can kind of recap that a little bit, the way I understand it is then your library that you're working on called exavier does an AST analysis and modifying at runtime the AST and rerunning different versions of the tests. And it sounds like it's even doing it concurrently where it's able to run multiple versions of the mutations. And then so if I also understand, please correct me if I'm wrong, but it sounds like the goal of mutation testing is not so much to validate our software as it is to validate the quality of our tests, that we are actually testing what we think we're testing and that we're actually getting the value out of our tests. You know, I can have like 2,000 tests that run and maybe they even run fast or slow. It doesn't really matter if they're not even testing something that's valuable. Like we talked with another guest one time where he deleted the entire source code for a file, ran the test, and they all pass. You know, like that's your worst case scenario, right? Like you're not even testing the code. So I think that this is an approach to help validate that I'm actually testing what I think I'm testing. I'm getting value out of my tests. So I can identify tests that maybe as the code has changed and evolved, it's not adding value. I can just perhaps even delete those tests. So does that sound fair?
Yeah, definitely. So this is a way to show that what you're testing actually like is a good set of, I guess, a good sample for what you're testing. So if you run your tests and if you modify the code and you see that with very little modification, you get the same results on the tests, it's exactly the same situation that you described. So that other fellow programmer, I'm sure he had like all the best intentions when he was writing that test, or maybe the test in the implementation diverged so much that eventually he could delete the whole source code and the test still passed. And so mutation testing is sort of an extra step here in the TDD cycle to make sure that what you're testing actually makes sense and it's useful. Now,
so one question I had was, where do you see this process fitting in? Is this something that I might want to have as part of my regular CI, where every commit it runs these, like I said, a mutation test, or is this something that I do more periodically? I'll run it against my code just to kind of check in and see how things are going. Like with property-based testing was something we've talked about a fair bit. Like those tests can take a long time to run. Does mutation testing run for a long period of time where that might be a consideration?
Yeah, so definitely. So a big disclaimer here is that I've never used mutation testing professionally, so as part of a CI build or something, but I've listened to talks and I've only played with it in my spare time. But from what I hear, what people do a lot of times is they will add it as part of their CI pipeline. And mutation testing, its core is very much based on this notion of a mutation coverage. So in unit testing, you have your code coverage, right? Like, was this line run? And then you check all of the lines and you do like a sort of percentage to have like line coverage and whatnot. And we all know that can be a bit brittle, but still, that's the coverage concept in unit testing. In mutation testing, what you do is you modify a certain source code with a given mutator, and then with another mutator. So imagine you can change an equals sign to a greater than or equals, or to a less than or equals. And you can do this through, a lot of different mutations the same source code running against the same set of tests. So what I mean is the same source code can be changed with a lot of different mutations and run against the same source, the same set of tests. What can happen is then you will start to accumulate the number of tests that still passed. And considering that number against the total amount of mutations that you run, you get the mutation coverage. So imagine you're running this, daily as part of your pipeline against the development branch that gets released to staging every day. Maybe you can have you can have it run as part of the pipeline. And when it hits below a certain mutation coverage, then you can raise flags and be like, maybe you should check the scope because this is like not, it's way below your quality grade for mutation testing.
I think that is an interesting idea because as someone who at times mentors junior level developers, one of the things that they're looking for is feedback on their the quality of their code, but also the quality of their tests. And it's not the most enjoyable thing for me to sit and look at someone else's tests because as part of a TDD experience, I enjoy writing the tests as I'm writing the code. And that's kind of the way I approach it and think about it. So looking at it after the fact, you have to start thinking, oh, what did they not think about? And what are they, what are they blind to here? So I think this is an interesting idea of something especially helpful perhaps to that scenario where I'm giving feedback to someone else who's junior, even feedback to me, myself on the quality of my tests, especially as they age over time. So I think that's an interesting idea. And so maybe you could just mention a little bit about this. So you said you haven't been using this in production system. And I presume that's probably why you went and started creating this library so that you could, right? And so could you kind of tell us a little bit about where you see this library fitting and when you hope to be able to kind of announce this and share this with people?
Yeah, definitely. So, it's just the library is called Exavier, like you said, and it's going to be hopefully available really soon under GitHub, my GitHub, Serrano/Exavier. We can link to it in the show notes, I guess. And the idea, it was something that I wanted to do for fun initially, and I know that it can potentially benefit what I'm doing daily. So definitely, I see this if it's successful, and if I get it to a mature enough state that I can run it in as part of the CI pipeline at my company's projects. I think that'd be like the holy grail of having this, being used in real life scenarios. So yeah, definitely see it happening in the future.
So you mentioned that the mutations were in parallel. How does that work with recompiling modules and the fact that there can only be one of them? Does that introduce a lot of extra test failures if you're if you're editing 10 modules at the same time?
Yeah, that's a great question. So from what I've seen so far, what happens is I can only have one version of each module being compiled, like you said, Eric. So what I'm doing is I'm running the mutations on each module in parallel. So I can change potentially the module A and module B in parallel because they're not the same, right? But inside each one, I have different mutators that can be applied to that source code of module A, for instance. Imagine I can apply mutator M1, M2, and M3 to module A. I will then run sequentially the A modified with M1, A modified with M2, and A modified with M3, and so on. But I will be doing that in parallel with modules B, C, D, etc. So this is definitely a limitation and something that I've thought about. And we can do some nasty things like changing the name of the modules in runtime to make it maybe work. But that's maybe far ahead in the future. But definitely, it's a lot of interesting problems here regarding actually making it work for Elixir. Another one that I think was great of tackling and that led me to writing a blog post about a deep analysis of the exunit and how it works Of course, I could only cover part of it because exunit is just massively huge when you start looking into it. It's simple, but at the same time, you get the feeling that it's a lot of work has been put into it, which makes it great and makes it awesome for us developers to work with and a joy to work with. But one of the things is reporting the failures, because what you can do is, or at least what I found I could do, was use the formatter in a hackish way. So you know how you have the JUnit formatter to report XML? I would just like pry into that and add a formatter, a specific exavier formatter to the test suite, and then that formatter would report back to a gen server that I have running all the failures or successes of the tests running, and then I would accumulate that, and in the end I just do that gen server, the reporter dot report, and it will give me the results of running that. So I think like I really felt proud of using the formatter in such a hackish, dirty way, because at the same time it's such a powerful tool, the formatter, because it has callbacks for like when the suite is started, when the test is started, finished, and so you can get a whole lot of information from that. And all of those callbacks come with tags for each test, with the files that were run, and so I could really like get the feel for the power of exunit and the information that it leverages in runtime. So
this is a bit of an aside, but I have also abused formatters for good, I guess. So one of the Ruby gems I've done is RSpec API documentation, and that whole thing is just like it runs your test suite, and you have to add -- formatter, the rad formatter, and like then it does the same thing. So it hooks in, grabs everything, and that one dumps out documentation based on your test. But yeah, so the totally cool to abuse the formatter. Yeah, I mean, it was the way of doing it at the time, and I honestly didn't look much further than just like it just popped in my mind. Okay, how does JUnit formatter does it? And just went ahead with it.
Well, it sounds like you've had some interesting experiences and along this journey, and I know that you put out a really nice blog article not too long ago about exunit and then doing a deep dive. And I presume some of these, I don't know, was that part of your journey while you're trying to figure this out? You're like, let me dig into exunit and see how it's working. So, because I think it's a great resource, and we'll put that in the show notes as a link to that article. But maybe you could kind of share some of the learnings you had in the process. I don't know, anything you'd like to just kind of share about exunit and your discovery along that process?
Yeah, so definitely the blog post comes as a consequence of this work for exavier and the mutation testing framework that I'm building. And it was an interesting challenge because a lot of the things that, like the one that I'm saying here, for instance, using the formatter in this way to kind of aggregate the results of tests that were failing or passing, it led me to this journey of like understanding how exunit worked underneath the covers, like how it recorded tests. How does it know that a certain test has these tags? How is it so damn fast? That's one of the questions that I really wanted to have answered as well. Because being in projects where the pipelines take so much time to run, we have one of the projects that I work mostly with now, with some other colleagues, we have more than 1,000 tests now, and it runs in under 9 seconds. And we're always amazed by like how fast exunit is, right? And so these two things, like wanting to understand how it was so fast, and then wanting to understand some of the internals so that I could make exavier work, it really led me to this journey of understanding a bit of how the parallelization works, some of even the trade-offs in terms of readability that may end up happening in the way that exunit is made. Like I remember this, that there's something that I talked about in the blog post about like doing the loading of the modules with exunit server, and it's a bit cryptic, but I ended up like understanding how it worked, and it like when you just dig into it, it just becomes so much clearer. And at the same time, like you take a step back and you realize like, damn, these guys in the Elixir core team, like they're working hard, So yeah, it was definitely an interesting deep dive.
That is really cool. So I think it's kind of worth mentioning, just as an aside, like where the name Exavier came from. I think you expressed some ideas around that. I thought were fun.
Yeah, so the name Exavier comes from the comic books that I used to read as a kid, and that I'm sure a lot of our fellow nerd listeners as well read. So Exavier is the Professor X from X-Men, and yeah, it's just like the overall nicest, coolest guy with very nice superpowers, and I wanted to have him in some sort of homage, and this was the perfect excuse because you can use the EX to do some clever naming, I guess.
Yeah, and I think it's you were showing us like some of the output of your like a mutation test run, and it's like, was it mutants killed and mutants survived? And
yeah, exactly. So for the fellow X-Men readers out there, maybe I should have called this Sentinel or something, but I thought that Exavier was perfect just because it ties so nicely with the EX. So yeah, mutants and all that.
That's fun.
It's just starting up a school of mutants.
Yeah, hopefully a good one.
Yes. Well, is there anything else you want to mention about mutation testing before we jump into some interesting stuff you wanted to we could talk about Broadway?
I think that's it about mutation testing. I guess you guys just watch out, and if you want to help out, I'll have a nice to be done section in the README that you two have already seen, and there are a couple of ways that you can contribute if you are interested in this area, and we can maybe work together and make an awesome mutation testing library.
Yeah, I think you were just wanting to kind of put together a blog post, kind of introducing it and to kind of announce it. So I'll be looking forward to that, and I'll make sure to tweet about that and forward that on. So please follow me at Brainlid on Twitter, but also obviously follow Daniel. And so, but we'll give your Twitter and everything. You can go ahead and mention it right now. Why don't you?
So my Twitter handle is DNL Serrano. So that's DNLSERRANO.
Right. So if you're interested in following when this gets announced, hopefully soon, that'll be awesome. So I wanted to also talk about some really interesting stuff you're talking about with load testing Broadway. And what I thought was fun about it is you're using some tools that's like I used. So you mentioned this tool like Jmeter, which is an Apache project. And it's something I used a long time ago, back when I was doing .NET, to kind of load test a project and kind of demonstrate that this solution can handle 60 times more of the volume than this other solution. And it gives nice statistical analysis. And that was many years ago. It's been a long time since I've looked at it. I would love to hear about how you were approaching this with the kind of the needs that you were trying to solve at your job and what you're trying to do there.
Yeah, sure. So, this whole thing started with us going to, so me and some teammates going to Elixir Conf in Prague. And we ended up like seeing the announcement that Jose Valim did of Broadway, and we were thinking about using it. And we ended up actually using it in a very early stage still, and it worked nice and dandy. But we wanted to load test the application, see how well it behaved. And I can go into details about why we needed to use Broadway in a second. But coming back to Jmeter and why we used it, we had this senior engineer at the company, Ruben, a colleague of mine, who had been using Jmeter to test some other services in his team on the document side of what we do at Onfido. And so we had his expertise already of how to work with Jmeter, all the amazing graphs that you mentioned that it provides out of the box. And so we just, he had like a pairing session with our test engineer, Ulish, and they both created like the suite of tests to be run in Jmeter, the suite with like the requests and the expected responses and whatnot. And then they just load tested the app, and we got to see it shape a lot in staging. And so we had to eventually go ahead and fix it. And some of that had to do with, just a bad mental model of what Broadway was doing. And it came down to reading the manual, right? Understanding correctly what it did and what variables we needed to tweak when configuring it. And it was like a really good teamwork and team exercise, because we all got around to try and fix this problem. I think like in total, maybe 5 people, 3 backenders working on the project that was under load, and then the 2 guys that actually like did the much more of the work around the requests that were to be done and whatnot. Because they were looking at it more in the user's perspective, and us more in the, okay, how do we handle this much load perspective, and what do we have to do to fix it? So it was definitely interesting. And it came down to like misconfiguration of Broadway.
So before we get too far, maybe we should take just a tiny bit step back and I guess explain what Broadway is, just in case people haven't heard of this.
Yeah, so we've had some previous podcasts where we talked about Broadway, and especially when it was announced, very exciting kind of development in the Elixir space. And so one of the things that was interesting is that you have GenStage, which is an external library. It's not a core library. And then as part of GenStage, they have producers, and so they're coming up with a way to kind of put these all together and to kind of wrap around it some of the things that you need to do as a user of GenStage, and to like the proper shutdown of a system, how you're able to kind of drain the pool of what's being worked on before shutting down, kind of gracefully shutting down without dropping a work that's been partially completed. So they built Broadway as a way of doing that. And they called it Broadway because you have GenStage, like stages, and producers. So it's like Broadway as in like musical productions. So I thought that was a kind of a fun little background of like how it was named. So Broadway, but it's like basically a wrapper around GenStage that makes it easier to use in a responsible way. But it's
and the good thing about it is, I think that it comes in with built-in SQS support, and that was our use case at Onfido. Nice. So we were using the architecture that we have currently relies on Ruby processes doing huge jobs in rescue, and then they will eventually call each one of those rescue jobs. Will do a call to this service, this microservice that's written in Elixir that handles all the work, the heavy lifting of doing a bunch of parallel calls to research microservices that aggregate results that have to do with stuff like face matching and anti-spoofing and whatnot. So Elixir was a great use case for that, but we had all of this legacy work done already in Ruby that was, offloading the work to rescue workers and then just waiting on replies from that Elixir microservice. What was happening here was that each one of those workers, even though we have 2 ways of contacting Onfido, one synchronously and another one asynchronously, even when the request was asynchronously, the rescue worker would still, so it would be spawn up in an asynchronous way. So we would just hand the job to it and go away, do the rest of our job, do the rest of our work, and not care about it. But inside of it, the rescue worker would still hold a synchronous, would still be synchronous in the sense that it would still hold and wait for a reply from the Elixir microservice. So what we found here as a potential way of speeding things up and making it much more efficient was have it offloaded to an asynchronous, what we called the asynchronous jobs queue that would get picked up by this Elixir microservice. and that would process the messages as it could and as it had the ability. And then it would, after it was done, reply back to another queue that would be picked up by the legacy Ruby application. So it seems like the perfect use case for Broadway, right? Because they support SQS out of the box. So we just had this inherent pattern of producer-consumer. And so we just thought, we'll just go with this. And it made perfect sense, and it's working fine in production now. But before load testing, I must tell you, it wasn't that joyful.
I do want to kind of touch on something that I think is valuable to think about, which is the value of actually having an idea about how to solve a problem and then making the effort to actually load test it, rather than just like throw it out into production and say, well, let's just see if it blows up, right? Because when it's a small app and you're just kind of playing around, that's totally cool. No one cares if it goes down, really. It's not something critical. It's not solving a business need. But CEOs, they may not be very happy with that as an approach. So I think it's just kind of worth talking about like how you approach the idea of saying, well, we want to make this change. We see that there could be value here. We want to validate that it can actually scale to the level that we care about and that's important for our business. So just kind of maybe if you could share a little bit about the thought process about how you went about doing that. It sounds like you had some resources available inside your company that already had some experience. So maybe you could just talk a moment about that.
Yeah, definitely. So this senior engineer that I talked to you about, Ruben, he was, I think, inside of our company, the one that took it more seriously. And like he did the work of like having dedicated dashboards for when we were load testing the metrics that he wanted to look at inside his own services in his team. And then with that knowledge, and because, it's still a good enough size that we can still all talk to each other and we all know each other fairly well. So we were talking with him, and my team lead is actually also a big proponent of like load testing and seeing how things work at scale before they even reach production. And I'm learning a lot of that right now as well, because before and in previous places that I've been, we would do just that. So we would have the good enough solution that runs in staging or whatever development environment. And then, well, it's working here. Let's just put it in production and see if it crashes. And oftentimes what will happen is it will either crash or you will see major contention issues and bottlenecks in your application after the fact. And what we could do here is we could identify all of those prior to releasing this for everyone and seeing customers be affected and complaining and submitting support tickets and just overall like degrading the perception of our company. So I think, that's something that I'm learning myself. And I think that a lot of people inside my company have already embraced it much more. So I'm still learning as well.
So is that part of that process and that discovery, was that kind of what led you into distributed tracing?
Yes.
In terms of, having to diagnose what was going on and how to isolate where the problems and bottlenecks were? Definitely,
yeah. So part of it as well. We wanted to have distributed tracing for a while, and we had been taking a stab at it for numerous times. And that was also the subject of a talk that I gave at Elixir Conf in Prague about the small contribution that I did to Spandex, which is the distributed tracing library. But the really good thing here is that distributed tracing can help you identify the places where you have those bottlenecks, and together with metrics that you have collected of how much time you're spending in each area of your code in doing what, that really helps track down and pinpoint the issues that you're facing. And definitely that's one of the reasons why we bet so much on distributed tracing was during the load testing period.
So could you give a back up a little bit and just kind of share, like people may have heard the term tracing, like what is distributed tracing and how is that different?
Yeah. So distributed tracing is just a method to profile and monitor your applications specifically when you're in microservices architecture, you start to have a lot of traffic going on from app A to app B to app C. And when, you have an issue and you, from the user's perspective, you just see an error, you don't know at which point in that, shall we call it, pipeline of requests or flow of interactions between your microservices, you end up not knowing what happened in the middle, what caused the failure that you're seeing at the front. So what distributed tracing gives you is, by you submitting a series of specific headers tagged with what is called in the open tracing standard the span IDs, the request, the parent IDs and whatnot, you can see a full trace of your request within the different microservices that you have. And in that way, you can have metrics associated to it in terms of like the DB performance, like how much time you spend on a given query for that request. You can see that the problem was specifically in microservice X. For instance, at Onfido here, we do a lot of our technology deals with a lot of like face detection and stuff like that. So it's really fun to like open your dashboard and see that clearly the issue was that a face was not found in this picture. Like you can just see that the service that would do the face work just can't find a face. So you get like, we use Datadog internally, and you get a really big like red sign around the box of that microservice saying, here's the problem, and you should look into this. Because and when I say like the face not being there, it can either be because no face was there actually, or because our service has a problem and it wasn't trained with some like weird category of images. So it's really useful, and in a clever way of just passing headers around, HTTP headers around, you can get a full picture of your service architecture.
So is this distributed tracing, is that how you were able to get metrics out of the load testing to know that what you're doing was like actually doing what you're hoping?
Part of it, yeah, but the big thing I think were actually Datadog dashboards combined with Amazon CloudWatch metrics. And the big problem that we felt when using Broadway had to do, one of the problems had to do with the queue visibility timeouts, which basically just tells you how much time a message will not be visible after you've acknowledged to have picked it up. So imagine like you pick up a message from the queue, you hold it for like, say, 20 seconds. If the visibility timeout is 20 seconds, then it will get requeued because, it was picked up by someone, but maybe that someone crashed. You didn't receive an ACK after it was processed. So the way that it works is it will use that visibility timeout to requeue it so you can reprocess it. And it does this up to, in our case, up to 3 times. So what we were seeing is that we were getting a lot of those requeues happening in the processing. And we eventually tracked it down to, obviously the visibility timeout was set to something like 10 seconds or something. And we need a bit more than that to actually process a request. Specifically, we need to up to 3 times that. So what we were seeing is because this service does a lot of, like I hinted at before, parallel calls to research microservices that do a lot of things regarding face, anti-spoofing, and whatnot. And those algorithms are inherently a bit slower than your usual like operation, CPU operation, because it has a model associated with it, and it's fairly CPU intensive. It takes a while, so we were taking a bit longer than expected, and we could just tweak that value, that visibility timeout metric, to just be some other value. And that would then get us the way to actually process the request so it wouldn't get requeued and we could process everything as expected. But then another problem came along, which was now we were being able to process the messages, but after a while, we still got the visibility timeout. And we now didn't understand why. Like, why are we getting the visibility timeout if we are being able to process the messages in their time? What was happening was a configuration in Broadway. Because we were setting the minimum and maximum demand wrongly, we were actually consuming more messages from the queue that we could actually process. So we would like pick up, I guess it was 10 or 20 in a batch and then try to process all of those, but we couldn't because of contention in the Python microservices. So because those research microservices are obviously written in Python, popular language for research stuff. And so we tracked it down to having to tweak minimum and max demand. So long story short, the solution here was read the Broadway docs before you get too excited after you listen to the talk in Elixir Conf.
Yeah, and then also try to validate the design with some load testing. But I am curious, like after you've been through this process and what's your end result with Broadway? Are you guys happy with the result of it? Is it doing what you want?
Yeah. We're totally happy with it. We've seen like the most amazing graph in terms of like the time that a worker now spends, a rescue worker now spends actually doing some work. Because before it was like, we offloaded the job to rescue, it would do the request and hold on for that response. And now it just like enqueues the message and it's done with it. And so that has allowed us to not spend as much resources in terms of like number of rescue workers doing that sort of, I'm missing
just like waiting for IO time.
Waiting for that IO time, exactly. And we can now do actual work that we need to do in that legacy app, because I'm sure you guys can imagine that a legacy app does a lot of stuff asynchronously, like with the rescue workers. And so it wasn't just stopping for IO there. It was stopping to actually, not serve PDFs or something like it. So it's really important to sort of offload those sorts of tasks that you can to and think about another way of architecting things. And that was like a major win for us. This is obviously not just done by me. It was a joint effort led by my team lead, João, and also with a colleague of mine, Daniel. And it was overall, like, we were super happy with Broadway. It's serving us very well in production, powering like real user interactions and making our lives and our jobs easier.
Nice. That's a testament to success. So one of the other things I think was interesting, because you mentioned Spandex as the library that you were using to help do some of the distributed tracing, which is able to do its visualizations and send the information to Datadog. I saw a talk where you were at the Elixir Conf EU, where you were kind of talking about your journey. I liked your title. It was like noob to contributing noob. And
yeah,
so we'll include a link to that talk so people can check it out. But I was just kind of curious about how your experience learning Elixir and in the community, what that's been like, and how rewarding or frustrating, or kind of what your experience has been.
So I got to know Elixir around I think 2015 maybe, and it was through two other engineers that I know from the previous company I worked at, and they kept talking about it. Like I talk about it in that talk that you mentioned. They kept talking about it, about this like new language that was created by the guy that was working on Devise in Ruby, and at the time I sort of brushed it off, and I didn't care much about it, to be honest. But then when I was interviewing for this company that I'm now working at, the director of engineering there, Paulo, was super excited about it. And he was saying like, oh, this is like the next best thing. Like it sits on top of the Erlang, and their Erlang is so great, and like used by Ericksen, so scalable, and like Ruby's yesterday's news. And I was like, okay, like, but I'm going to be doing Ruby, right? And he's like, yeah, you're going to be doing Ruby, but like, but Elixir is so cool, and maybe we can have some cool projects in here. And yeah, like I heard about it, so then I was more kind of interested in it because I was seeing my new boss being excited by it. So I guess it's a good omen to be excited about it as well. And then these two colleagues of mine, Andre and Daniel, they have actually wrote a book called Elixir in Action. And so they had a ton of experience in the language. And my team lead, João, has written and developed 2 series of webcasts for Pact on Elixir basics and then on OTP, advanced OTP. And so like, it was a lot of knowledge built in-house, and for a small company, well, not super small, but the office here in Portugal is fairly small still, and it was a lot of knowledge built up there, and so like I had to learn from it, and it was just a joy to work with. The language itself, the community is very like embracing of new people, new backgrounds, and different ways of looking at problems and of solving them. And I think like the experience has been great so far. I can only like speak and tell good things about the Elixir community. Like I say in my talk, I don't think it's like a coincidence that Jose Valim comes from the Ruby community. I think that he helped shape that community there, and it's now bringing that niceness that he has and his way of dealing with things into the Elixir community. And I think we have like a lot of great people, like you guys with the podcast as well. There are like lots of, the podcast community is great actually in Elixir. It's like we have like 3 or 4 podcasts, and it's, I mean, everything is just a breeze. Yeah, loving it.
Awesome. So one of the things I think I just want to touch on briefly is the idea of like noob to contributing noob. It sounds like even though you're actually contributing to other libraries, to authoring your own library, there's still a sense of, I feel like I'm a noob. And right, and I think is that part of that imposter syndrome? Do you think?
Yeah, definitely. I think the imposter syndrome is very real, and I feel it. But yeah, it's just also the idea that like you don't have to be this rock star developer to start contributing and to give back. I mean, I knew nothing about like the process dictionary before I looked into Spandex, you know, and it just so happens that Spandex, the distributed tracing library, uses the process dictionary, and so like I learned something and I could contribute back with something, and it also turns out that I could only because the people there were nice, Greg Mefford and Zach Daniel. So you know, it's just like go for it, and I guess if you don't know stuff, just ask, and eventually I think what I've come to find is the Elixir community is nice enough to just explain instead of like bashing or like something weird. So it's been great, but yeah, still a noob, forever noob.
That's right, forever growing, learning, right? But that's been my experience too, that it is a wonderful community and I enjoy being a part of it. Well, is there anything else that you wanted to talk on or mention before we go to picks?
No, I think that's it.
All right. Well, let's go to picks. Eric, do you have one to share?
Yeah. So I've been, I guess this sort of ties in a bit with some media announcements. So I just started rereading The Wheel of Time. So I hadn't finished it before, but there's a TV show coming out sometime in the future within the next year, I think. And a few other things that have kind of lined up. So I've started rereading The Eye of the World. I just finished that last week. So definitely can recommend that. And if you like big epic fantasy, there are a lot of them to read. So
nice.
Awesome. I was going to share one. It's from our talk that we had last week with Brujo. I don't recall if this was mentioned as part of the discussion, but it was this fun talk. It's less than 5 minutes long. It's called WAT, like W-A-T. It's a lightning talk that was given by Gary Bernhardt back in 2012, but it is hilarious. It's really well done. It's just making kind of like the funny little quirks of Ruby and JavaScript and just super entertaining. So I would recommend that one. And I think I'll do one more, which is there's a service that's been in use now from Firefox, from the Mozilla Foundation. It's called Firefox Send. So it's at send.firefox.com. And what is handy about this one is it gives you the ability to securely send large files to other people who don't have to have an account even. And you can specify that I want this to be available for a certain period of time, or for only one download or two downloads, or whatever kind of requirement like that. And it can be like 1.5 gig. And if you set up an account, then it can be like 2 gig or so, something like that. But it's sometimes when you're wanting to share, maybe like you recorded a video and you want to share it with somebody, and you don't want to, Dropbox may not be the easiest way or the preferred approach. So Send Firefox is a fun one to try. So that's it for me. Daniel, how about you?
Yeah, so I have, I guess, 3 picks. So the first one is a TV show. I've been watching Dark, a German TV show, sci-fi, with my girlfriend, and we just binge watched the 2 seasons really quickly, and it's just great. If you like stuff like Lost and I guess even Stranger Things, and I think it's way better than Stranger Things. No offense to American TV shows, but this German one is just awesome. So yeah, go watch Dark on Netflix. The second thing I'd like to mention is Lightline. So I use Vim. I've been a Vim user for a while now, and I don't want to get the whole editors discussion started, but it works for me. So this plugin is called Lightline.vim. I've been using Vim Airline for years now, and this one is lighter in way of thinking about designing it. The features that it provides is just less stuff, and I've been wanting to sort of minimize my whole life, I guess, after I watched that minimalism documentary. So that can be reference number 4, I guess. And the third one would be Flow, the library that the core team of Elixir have developed. I know this has been around for a while, but I was having to do some ad hoc scripting for getting data out of a database the other day, and in a breeze, I could get parallel queries to the read replica that I was using, and I got it all together and dumped it into a CSV in no time. And I would have had so much difficulty in hard coding all of this parallel logic with demand-driven architecture if I were to do it myself. And I literally just had to add some lines to mix, add some lines to my script, turn that enum to a flowable enumerable, and then I was done with it. It was a breeze, super nice to use and so useful. So I definitely recommend anyone who's just heard about it and doesn't think maybe you'll be over engineering. Believe me, maybe you won't, and it can be that useful. So yeah, that's my last pick.
No, that is cool. Yes, you're right. Flow is something that has been around for some time, but it is worth talking about because there's a lot of value there. And I think it's a great little testament that you gave there. And it's worth talking about also because there's continually people coming to the Elixir community, and there's a lot of stuff that, since it's not part of the core library, it's worth talking about and making people aware of it. So thanks for sharing that. Well, Daniel, it has been awesome talking to you today. I really appreciate it. We've covered a lot of material here. And so I encourage people to check out the show notes. If people want to get in touch with you or follow you, where would you direct them to go?
I think Twitter is probably the best place, twitter.com/DNL Serrano. But I also have a website where I blog. So that's dnlserrano.dev. And I can also link to that in the show notes.
Awesome. Well, that's it for today. Thank you for listening, and we hope you'll join us next week on Elixir Mix.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with